Hi, I'm going to talk about the program Zinfadel, and what we're looking at is the desktop on my computer, and I've put Zinfandel here in my dock. It might be somewhere on your desktop, or it could be, excuse me, I guess I had a word I was working on before, somewhere in your applications folder. When you find where it is, what you simply want to do is click on it, and it'll say Zinfandel. And when you do that, let me try it. You get a small window up here in the corner, and you can make this bigger. It's not necessary, but I go to the part that says Window, and it gives you these options: two-dimensional, three-dimensional, guess, mapping, planets. I haven't worked with these, but what I have worked on is two-dimensional. So I'm going to click on that, and that's what you'll need to be able to click on to do the activities that I'm going to give you in the next few days. So I'm going to click on two-dimensional, and I get a screen that's like this, and I'm going to maximize this screen so it gets up here. And so this is my y-axis, this is my x-axis, and again I have a number of things that I can choose up here. File, which means I could probably print what I want to some particular place, and maybe copy to a clipboard and use this for something else. Equation, which I'm going to come back to. View, so it allows me to view in and out, shift it, fit to a window, restore. I haven't worked with these. It looks like I can change my axes if I want. I can change my grid. And that gives me some other ones called one, which is measurement initial value problems. I think I can animate with this, and you have some things with settings, and I haven't worked with these. I basically go to equation, and under equation I have some forms. I have explicit form, which means an equation like y plus x equals 7 would be explicit. Explicit would be y equals x plus 3. Parametric implicit would be x plus y equals 3. I could draw in polar coordinates. I could draw a single point, a segment, a line. And then down here I could have recursive formulas, differential, a polynomial, and intrinsic curve. Well, for the activity, you're going to want to go under equation and come down here to differential, because that's the topic of this particular chapter. And if you notice, I have three choices: dy dx, dx dt, and x dot n, and I do not know what the third one is, but we're going to work almost exclusively on dy dx. And so when I click on that, what you'll see, it's already put an equation in here which I can delete. And so I just clicked on that box, and I'm just going to delete that, and I'm just going to simply have the equation dy dx. So that means the slope is dependent upon whatever x is. So where x is 0, my slope will be 0. Where my x is 1, my slope will be 1. Where x is equal to -1, my slope will be a -1. So I'm going to graph that just by saying OK. And if you know, what happens here is I have a slope field that occurs. So at every single mark in here, I have this, and you can kind of see that the curve kind of goes like this, and that I have a parabola. And I'm going to close this now. And I can come up back here, and I'm going to pick an explicit equation. And the explicit equation, I'm going to delete. Again, it has one that starts with. I'm going to start with, if I take the antiderivative of y equal, or dy dx equals x, I'm going to get 1/2, or 0.5 x, and I'm going to use my upside down v, or my caret, to get my power 2. And if I write down -1, that will be my c, and you can see it fits that in there for me. So that's that particular equation. I can put another one. Let me try another one here. Again, it's explicit, and again, you always start out with this one equation that you have to delete. And I'm going to go 0.5x plus 1. So my c is 1 on this particular one. Oops. Except, let's see if I can undo that. View. Wonder if I can. I'm going to have to look at that and see if there's a way to undo that. That's not what I wanted, so I'm going to have to redo it. Let's go to explicit again, and I wanted 0.5x squared plus 1. And now I'm going to have that ugly one sticking in there, but you can see it's up here. So you got to be careful what you type, but you can see here I can get a family of curves, which is what this chapter calls me a family of general antiderivatives, or a family of curves. Let me do another one here, and I'm going to open a new one. And the equation I'm going to pick here again, I come down here under equation, I go to differential, I'm going to choose dy dx, and this time I'm just going to put in y. And if you notice, here's my y ones. I wonder if I keep that. You can see that my curves kind of look like they go this way. They're headed up. And down here they're headed down. So they kind of fan out as they go through. And we're going to talk about what these are, this particular equation. I'm just kind of fooling around here. I'm going to try a new one. Explicit again. I'm going to have x minus y. I'm going to put that one in there. Oops. I wanted, let's delete this one. Let's go to a new. Okay, let's try this again. Equation. Come down to differential and type in there is x1 sy, and then I have these, and you can see they're kind of heading over. This equation I had talked in class right along here is really close to where x minus y. Take a look, some of these have a slope of x minus y. That means y equals x. Or let's take a look here. 0 minus 1 is a negative 1. So about here I have a negative 1. They're not exactly here. I'd have a negative 2. Right here where x equals 1, right here they'd be equal to 1. And it kind of gives you the fractional parts, but you can see how they turn and come through. And so if I could figure out the general solution for this, which is what we're going to talk about, then what I would do is I would close and I would come back to here to my equation, type in my explicit equation for that, what I believe to be true, and I could graph it right in there. And we'll talk about how to do that and how you can get some options to do that. Let me try a new one. And I'm going to put in, I'm going to put in y equals x again. I'm just going to show you one little method that I can use that we're going to use further. So I got dy dx is equal to y. There's that graph. And I'm going to close this, and I'm just going to minimize this for a second and bring this up. They're trying to sell me something all the time. Okay, so let's take a look at this. I had dy dx is equal to y. Well, what I can do is I can multiply both sides by dx, and I get dy equals y times dx. Well, y really belongs over here with the dy, so I can write this as 1 over y dy. And you may have seen this before, and where this came from. And what I'm going to do is, like I can add to both sides, subtract to both sides, what I'm going to do is integrate both sides. Again, I'll be reviewing this later on. And so this is really 1 dx. So the antiderivative of 1 is x plus your constant. And on this side, this is the natural log of y. And you may remember us taking the derivative of the natural log of y and getting this as an answer from some problems. Well, what does this mean? This means I have a base of e, because this is log base e. This is my exponent, and this is equal to y. Well, this is the same as e to the x times e to the c power. And c is a constant. It's approximately 2.718, and c is a constant. And when you take a constant, raise it to a constant, you get a constant. So my final expression for this is c, that's what this is, times e to the x. Okay, so this is my general solution for this. Now, I'm going to close this, and I'm going to bring back this, and I'm going to put in the equation. Again, it's an explicit one, and I'm going to write down 2 e to the x. And the e I got is just from the keyboard. Press OK, and you can see it fits right in here. Let me try another one. Again, explicit e to the first power. Let's put that in as our, let's make this, constant goes here. Let's make this, let's just make it that and just make it 1. So that's my c. And now it makes a different color. You can see it goes in there. Now how would I get these down here? Well, I'm going to change my c to negative. Again, explicit. And I'm going to have a negative 2 e, just the e from the keyboard, raised to the x power. And here's this one right here, and this one's in black. And I'm going to do one more. I'm going to put in a negative 0.5 e to the x power. And you can see it fits right into this slope field. All right, hopefully that helps you with the worksheet we're going to be working on.